Now for task 3, we have here to determine the rounded value of the given value r, and it's given in the base 10 as decimal number, and we have 4 placeholders for the magnitude of the mantissa here. So working on it, let me write the value r again. So our r is equal to minus 102.378437.2. So we have to round it up for 4 placeholders. We're given only 4 placeholders for the mantissa. And the 4 placeholders will fill in significant digits from the number that we are given. So the significant digits are any number that starts with 1 to 9. From there onwards, every number is significant digit, and previous to the number 1 to 9, if you have zeros, those are not significant. So if you have a number like 0050, in this case the significant digits are 5 and 0 because they make sense. Like for if you want to say about OMR, in that case it is 50 OMR here, but the 00 makes no significance to the 50 OMR. So here now, if you look at the significant digits, we have 1, 2, 3. These are the 4 significant digits that will fill it up for the mantissa. And then we'll round it up and we'll check the next number. Is it greater than 5? Yes, it is greater than 5. So in that case, we'll add 1 to the 3. So the rounded r will be minus 102.4. That would be our answer. And for the next task that we have, we have to determine the rounded value of r, another number given to us, and this time also we have 4 placeholders for the magnitude of the mantissa. So let's try working on that now. So we have task 4 solution here, where the r is equal to minus 0.003784372. So now we have to again have like 4 placeholders like above for mantissa, and here now comes the point about significant figures. So the zeros at the beginning, they have no value here. So the significant digit starts from 3 here until the 4. So these are the 4 significant digits, and we check the next value. Is it greater or less than 5? Here this is less than 5. So in that case, we'll not add 1 to the 4, and our rounded value of r will be minus 0.0037884, or you can more precisely say it's minus 3.784 times 10 to the power minus 3. As I shifted the decimal 3 steps that side. So here now you can see we have 4 placeholders for the mantissa, and that's how we filled it, starting from significant digits, like starting from a significant digits, or you can say all the values in the placeholders are significant digits. So now the next question here is to determine the absolute true error and the relative true error of this approximation. So let's work on that. So the absolute true error which is also written as this one here, is the rounded value of r minus the value of, or the true value r. So here we take the absolute value of the rounded value of r, which is minus 3.784 times 10 to the power minus 3, minus we have the original value or the true value, which is 0.003784372. Okay, I cannot write that there, so here's the above. Okay, and we take the absolute value of this here, which gives us the value 3.72 times 10 to the power minus 7. Okay, now we have to find out the relative true error. And this is actually the absolute error that you have here, or let's write it like this one here. So we have the absolute of the absolute true error value, which was the rounded up r minus the true r divided by the true r. So that gives you the relative error, and the absolute value of it we have to find out now, which is 3.72 times 10 to the power minus 7. We take the value from here, absolute error, divided by the true value of r, which is 0.003784372, and this gives us the value 9.830 times 10 to the power minus 5. Originally this is not the number that we actually get. Maybe let me show the actual number first that we get here. So from your calculator, the value will look like this. It's a negative number because we have absolute value here, so we'll take only the positive part. So we have 9.829900443 times 10 to the power minus 3. And here we'll have only 4 placeholders for the mantissa, so we'll take the first 4 significant digits and then we'll check the next one greater than 5, so we'll add 1 to the 9, and that the 9 will be now 10. So we have a 0 for the 9, and a 1 will be added to the 2, giving us 3 here, and then we have the 8.9 here times 10 to the power minus 3. So that's how you get 9.830 times 10 to the power minus 3 for the 4 placeholders given to us for the magnitude of the mantissa here.